Hello everyone, welcome back. So this is today contest problem and we have to convert a binary number, a linked list to integer. So the question is saying that given we have head and which represents or you can say reference a node to singly linked list, right? As you can see here. So the value of each node in the linked list is either 0 or 1, right? And the linked list holds the binary representation of number. So we have to return the decimal number, a decimal value of number in the linked list. The most significant bit is at the end, at the head of the linked list here. Okay, so we will talk more about the problem, how we have to approach it, right? So let's continue to understand. So the example, as you can see here, we have given is head we have given 101 and it represents like a linked list and we are getting output like 5. Okay, let's dive into the problem and concept behind the problem to solve it. So this what the problem is asking, right? Problem is given a singly linked list where each node store either 0 or 1, right? A bit, either 0 or 1. The whole list represents a binary number, correct? It was given 101, remember? So the whole list represents a binary number and you need to convert that binary number into a decimal number in the base 10. That is the normal number system that we have, right? So the important is, what is important that we have given here? The first thing is saying that the first node head is the most significant bit MSB. And the last node is the least significant bit LSB, right? LSB, correct? So very first, we should understand, if you are beginner, what is a binary number. A binary number system, you know, that is a number made of only zeros and ones, right? That is called bits. For example, the binary number 101 means 1 into 2 to the power 2 plus 0 to the power 0 into 2 to the power 1 into 1 into 2 to the power 0. If you will do the sum mathematically, you will get this is 5 and the decimal number. How this works, we'll understand later. Now understand what is the most significant bit MSB and the least significant bit LSB. In binary number, you know that each digit has a position and weight based on the power of 2, right? So the left most bit is, you can say, is the most significant bit MSB and it carries the highest value, right? So as you can see, if we'll say this is our 101, can we say that? So this binary number 101, this is our leftmost bit, we can say that, right? And so we call this as a MSB, most significant bit, that carries the highest value, correct? Then we can say the rightmost bit, and it is a least significant bit that carries the smallest value. Can we see that? We can see that, right? So this is what happening, right? Whenever we are talking about the binary system, right? In the binary system, in the binary number system, we can say each bit, right, each digit, that is called bit, right, has a position. These are called position. This position is MSB, LSB, right? And this is middle one, normal one, right? So we understand more about these things, but just think that what is MSB and LSB, right? And these are the position we have given. Let's suppose if this is at 0 position, then this 0 is at 1 position, this one is at 2 position. So these are the positions we have. Positions have a very good important role in here, because this binary system contains how many bits? 3 bits we have, 101, correct? So how we are going to utilize through the position? So each position corresponds to the power of 2. How? So the position 2, let's suppose for this I am talking about, 2 to the power 2 is 4. Its value itself is 4. Similarly, for this we can see the value, right? What you need to do, if you are going to convert 101 to decimal, right? You know this is your value, right? And these are the bits we have given. You just need to multiply it. right? And you will get the exact value in the decimal. You just need to do plus. If you'll do the total, you will get 5. So the binary 101 is equal to decimal 5, right? So how linked list fits in this? So the if we are talking about the given uh, linked list, right? We can say single linked list. If the input is the linked list like this, right? Like 101 we have given, right? Then this means the first node is the most significant bit, right? That is 1, and the second node is the next bit, that is 0, and the last node is the least significant bit, that is 1. So the binary number is from left to right. And so we can say when we are going from left to right, right, it means we are going head to tail, right? And so we can say we can take 2 to the power 2, 2 to the power 1, 2 to the power 0, right? Can we say that? We can say that, right? And so we can say the bit position is how, if we'll take the bit position, right? 1 0 1, right? The position from right to left is 2 1 0. We'll do the power of 2, you will get like this. If you multiply, you are getting this one, and you are converting this value, right? So this will fit like this. Okay, let's suppose example 2 we have, right? We have 0, the binary number is 0, and the decimal is also 0, right? Because there is only one bit is there. 2 to the power 0 is, you know. So what we need to do, we need to uh, traverse the linked list from head to end, and we'll treat each node either 0 or 1 as a binary digit, and we'll convert the binary number to decimal base 10 number system and return the result. Okay, now understand the intuition. So we have given a linked list, we can say, right, like this. So each node contains either 0 or 1, right? So this is a binary number system. So you need to convert this binary number into decimal, right? So if you think that this is your MSB, this is mid or normal, we can say, and LSB, right? It means what is the linked list means here, right? Means the first node, that is head, is the most significant bit, right? And it represents the leftmost bit of the binary number system, right? And so this list, we can say, represent the binary number. Okay, so when we are converting binary number, so 101, so we treating this is a positions, right? 210 012, right? From here to here, right? We can say that we are treating this as a 012 as a position. If you are taking the power, we are getting like this, right? So when we are talking about, when we are talking about the positions, we are going from right to left, right? Means least to most. This is list LSB, this is MSB, right? But we are talking about binary, we are going from most significant to left significant, right? And these things we are doing the same exactly. But think how we are thinking. When we are talking about the position, we are going like reading like this, and we are talking about the binary, we are going like this, right? So the binary to decimal, each bit has a place value that comes from its position, that is power of 2. When we are taking power of 2, we are multiplying with its power, its position, right? So when we are multiplying this, means each bit has a its place, right? And these places gives you the power of 2. Can we say that? And so we are getting the value, right? We are from the first node, you will get 4, second node this, and then this, and you will add them and will get the value. Now the intuition behind the code is, now instead of calculating the power of 2 from the right, what we can do is, while reading from the left to right, using the trick. So the formula we can take, let's suppose while traversing, there will be result, right? We'll multiply into the result by 2, and we'll say the current node value will add. We'll keep adding this, so you will get the result. Or what you can do by the bitwise operator, if you don't want to use this one, we will use bitwise operator, and we'll say result left shift will take, right? Or we'll say the node value, right? So we'll shift the result left, multiply by 2, you can say, and we'll add the current bit, right? What is the current bit we have, that we will add here. So meaning is same. Okay, so the final intuition, we can say that a binary number system is made of 1 or 0. So each bit has we can say power of 2, right? Means and the first node is equal to the head, we can say, and it is a leftmost bit, or we can say the most important biggest weight, we can say. We'll traverse the linked list, we'll keep shifting the result, we'll multiply by 2, and we'll add the node value. At the end, you will build the decimal value. Let's understand the implementation. The very first, we have given class, we have given, and this function we have given. So this function contains what? List of node, right? You know the list node, list class, right? So there will be a current node and next node we have given. So let's suppose this is our head, right? So what we will do, very first we'll take the result int equal to 0, we'll initialize the result, and we'll say while head is not null, means we have to iterate now, right? So we have to iterate until the head is not null, and we know we have talked about this one. Result is, we'll do multiply by 2, and the current value we will add it here, right, each time. So we'll get the value. Next we'll move to the next head, right? And so we'll get what? Head dot next, you will get the head, right? Until the head is not null, we'll keep adding the result, means we keep appending the result. Means what we are doing here, we are uh, shifting all the bits to the result right here, and to the left one, and we are multiplying each time by 2, and we are also adding the current head value from here. Either it will come 0 or 1 from the current node, right? So we'll keep adding into the result both of this, and then we will move to the next node, right? And then finally we'll return the result. Okay, we'll do the dry run, don't worry. So okay, you have to dry run here still. Okay, so let's understand the node we have given was what? Give me 1 second. So node we have given is 1, right? Then we have given is 0, and then we have given is 1. Can we say that if this linked list we have given, right? So the very first we are taking a result as a 0, right? So when we are talking about the first node, when we are reading, let's suppose we are going to read the first node, right? So head, we know that head is here. This is our head, right? And head is here. So when we are going to read the first node, what will get the value? We'll get value is equal to 1. Can we say that? Means we have to apply this formula, right? So what we will to do, we'll say result is equal to uh, that is what we have, result initially 0. R is initially 0, result is 0, right? So will result is 0, we'll take left shift, right, and we'll take the value 1. And what is the current value? Current value is also 1. So this is our current value, and this is our shift value, right? And we have to add the value. Means if we'll talk, it will give you what? It will give you 0. This will give you what? 0, and this is our, we have to add 1. Can we say that? Now if we'll add 0 and 1, what we'll get? We'll get 1. Understood? Means linked list pointer moves to the next node now, right? After generating this value. Now this is done. Now the head will move to here, right? This head will move to here, means 0. The value is what? The value is 0, correct? Now result will become what? This is, previously result is what? 1. So we'll put 1. We'll make a shift. What is the current value? Current value is what? The value is what? Here. That's a 1, right? We'll take 1. Now we'll take the value of the current value, right? Here. You can check here, right? We'll take the shift, right? The head dot value is 0. And we say that now if we'll find the value, 1 shift 1 is, we'll get what? 2. 2 into 1 actually. 2, this is meaning what? 2 into 1. Right? It was meaning of 2 into 0. So we are getting what? 0. Right? But here 2 into 1 is 2. And then we'll get what? We have to add 0. Right? What we need to do? We'll get the 0. Now will 2 plus 0 is 2. So current value is 2. Then we'll move the head here. Right? This is our result. Right? So let's suppose, okay, let's suppose we'll take v equal to, this time is 1, right? So we are going to find the result. What is result? We'll take 1. Can we say that? 1. Previously it was what? Result. Result is 2. Sorry. We'll take result is 2. This is result, right? We have to put first result, and then we have to do shift, right? then shift with 1, right? Then we'll take head dot value is 1, right? So 2 into 2, what will get 4, right? And the one we have to add, 4 plus 1 is 5, understand? And that is why we are getting the result 5 here. So just once your head is done, you are doing head dot next. So you are moving head from here to here and then here like this until the next is come null. It will keep, this loop will keep increasing, and finally you will return the result. I hope you understand. If you still have any doubt, please let me know in the comment section, right? So apart from this, guys, there are multiple approaches that you can solve this problem, right? You can use, we have used the bitwise operator, right? Bit shift, we can say bit shift, or you can say shift, right? This approach we have used here, bit shift, where we have take so the time complexity, if you see, it will traverse for all the node, right? And so it will take what, O of n, right? We are not taking extra spaces, so it will take O of 1. This is the best in the performance and space, right? And apart from that, if you want to go with the space O of n, there is multiple approaches that you can use. You can use string builder plus parse, right? You can use recursive approach, right? You can use reverse and multiply, right? So you can try all of them. That will give you the O of n and O of n, right? So this is your time complexity and this is space complexity for other, right? Let's suppose we are talking about the builder, recursive, or either reverse multiplying, right? You can try by yourself. Let me know if you want to dive into that topic. Okay, please put me in the comment section that you want to understand. I'll create the video for you. Thank you guys. Thank you for watching this video. If you like this video and if you want to support Expert Funda, just hit subscribe the channel and give a like, thumbs up. And if you have any suggestions, please put me in the comment box. And that's all for today. I'll see you in the next one.